Hi everyone, today I am going to explain the complex analysis topic. So that is finding the derivative of an analytic function. So before going to this topic, let me explain the working procedure for the problems. Say for example, if they have given w equals f of z means first we have to substitute w as u plus iv and f of z in that is f function given problem, it will be in terms of function z. Then we have to substitute our z in terms of x plus iy. This is a complex number in the Cartesian form, and we have to separate the real part and imaginary part, that is u and v. Suppose if it is complicated to separate our real and imaginary term in terms of Cartesian form, then we will prefer our z in terms of polar form. So what is a complex number in polar form is, that is z equals r into e power I theta. So we used to go with the polar form. Whenever it is complicated to separate in Cartesian form, by that time we will prefer the polar form. This is what the first step. And the second step is, after separating our u and v, then we have to find out the first order partial derivatives. Say for example, if we got our u and v in terms of x and y means, then we have to find out first order partial derivatives dou u by dou x and dou u by dou y. Similarly, v with respect to x and y, that is dou v by dou x and dou v by dou y. Then we have to check the CR equation, that is Cauchy-Riemann equation in the Cartesian form. What is the Cauchy-Riemann equation in the Cartesian form? Means dou u by dou x is equal to dou v by dou y and dou u by dou y is equal to minus dou v by dou x. If they are equal means, then we will say that the function is an analytic function. Okay, and the third step is, we have to find out the f dash of the z, that is derivative of f of z by using the fundamental result, that is f dash of z is ux plus ivx, that is ux means dou u by dou x, vx means dou v by dou x, that is in the terms of Cartesian form. Similarly, if we want to calculate, suppose if we have solved the problem in terms of polar form, then our formula f dash of z will be e power minus I theta into ur plus ivr, that is in polar form. So finally, after taking this formula, we will substitute our first order partial derivative values ux, dou u by dou x value, and similarly dou v by dou x value. Then we will simplify the terms in terms of x plus iy. Whether if we have solved the problem in terms of Cartesian form, we will simplify in terms of x plus iy. Suppose if we have solved the problem in terms of polar form, then we will simplify in terms to r into e power I theta to get f of z. So now let me take one problem. The question is, show that f of z is equal to sin z is an analytic function and hence find f dash of z. So here we can see the two parts of the question is there. The first part of the thing is, we have to show that our function sin z is analytic function, and the second question is to find out the derivative of f of z. So f of z is equal to sin z. So now here f of z I have taken u plus iv, and similarly here we can observe the function is sin z. So here z I have taken x plus iy, that is a complex number z in terms of Cartesian form. So now if we see the term, this is in terms of sin of a plus b. So sin of a plus b is nothing but sin a cos b plus cos a sin b. And also I have used one more result, that is cos iy. Cos iy is nothing but cos hy. Sin iy is nothing but I sin hy. So that both the formulas are mentioned here. So now you can see here, and why I have used this formula means, because in the first term also I term is there, in the second term also I term is there. Here we can observe here real part and imaginary part are not separated. So for that purpose only cos iy I have used as cos hy, and similarly sin iy I have used as I sin hy. So now we can see here the real part and the imaginary parts are separated, that is u equals sin x cos hy, v equals cos x sin hy. This is our real part and this is our imaginary part. So this completes the first step of the working procedure. And now we will move on to the second step of the working procedure, that is to find out the first order partial derivative. So that is u with respect to ux, uy. That is differentiating partially u with respect to x means differentiation of sin x is cos x, cos hy is a constant, and differentiation of u with respect to y means sin x is constant, differentiation of cos hy is sin hy. And similarly, v with respect to x means differentiation of cos x is minus sin x, and sin hy is a constant, and differentiation of v with respect to y means cos x is constant and sin hy differentiation is cos hy. So now we will take our CR equation, that is Cauchy-Riemann equation, in Cartesian form, that is ux is equal to vy and ux is equal to minus vy. This minus you can take here also, it's not a problem. And now if you back substitute its value, I mean ux value is cos x cos hy, vy value is cos x cos hy, we can see here they are equal. Similarly, if you substitute these two values above what we have calculated here, that also will be satisfied. Hence, we can say if the CR equations are satisfied, means then we can say that our function sin z is analytic. So this completes our first part of the question. So now we will move on to our second part of the question to find out the derivative of sin z. So as we know, the derivative of sin z is cos z. So now that we will do in the complex way, I mean complex method, that is by taking our formula, that is f dash of z is equal to ux plus ivx. So ux and vx, ux means partial derivatives, what we have calculated earlier in the before steps, that only we have back substituted here. So ux is equal to cos x cos hy and vy is equal to cos y, sorry, vx is equal to minus sin x sin hy. So back substitute that value, and after that we can observe here it is using the result. This results we have to use here because cos hy is nothing but cos iy, and similarly I sin hy is nothing but sin iy. Why we are using here means to separate our real term and imaginary term, for that purpose. And if we see this terms is like cos a cos b minus sin a sin b. This can be written as cos of a plus b, because cos of a plus b formula is cos a cos b minus sin a sin b. So now what is this x plus iy? X plus iy is nothing but the complex number, that is z. So finally we will get f dash of z as cos z. So differentiation of sin z is cos z. This is only the final result. Similarly, we can find out the other problem also, f of z as cos z. We can try this. Okay. Thank you.